Good day. Our topic is about solving logarithmic inequalities. But before that, we are going to discuss first the property of logarithmic inequality. Property number 1. It states that if b is greater than 1, then x sub 1 less than x sub 2, if and only if log of x sub 1 with the base b less than log of x sub 2 with the base b. Example, log of x with the base 4. This 4 here is our base, which is represented with small letter b. So b is equals to 4. We all know that 4 is greater than 1. Therefore, b, which is equals to 4, is greater than 1. In this case, the direction of our inequality is retained. Property number 2. It states that if b is greater than 0 but less than 1, then x sub 1 less than x sub 2, if and only if log of x sub 1 with the base b greater than log of x sub 2 with the base b. Example, log of x with the base 1/2. This 1/2 here is our base. So b is equals to 1/2. We all know that 1/2 is less than 1. We also know that 1/2 is greater than 0. Therefore, b, which is equals to 1/2, is greater than 0 but less than 1. In this case, the direction of our inequality will be reversed. Now let's proceed with our examples. Example number 1. We're going to solve log of 3x minus 1 with the base 5 less than or equal to 1. So we're going to write the given, which is that 1. So in here, we are going to identify our base. So our base here in this inequality is equals to that one, which is 5. We all know that 5 is greater than 1. Therefore, b is greater than 1. So for our solution, since b is greater than 1, then the direction of our inequality will be retained. That is based on our property number 1. So I'm going to show you. So that is now the result of our problem. So as you can observe, the inequality symbol, which is less than or equal to, is retained. Now, after this one, we are going to convert this into exponential form. So to do it, I'm going to show you the formula for logarithmic and also with the exponential equation. So for the logarithmic equation, we have log of y with the base b is equals to x. And for the exponential equation, we have y is equals to b to the power of x. So to express this into exponential form, we need to identify the given. So we have b is that 1, which is equals to 5. Our x is that 1, which is equals to 1. Our y is that expression, which is 3x minus 1. So after that one, since we already identified the given, so we are now going to use the exponential equation, which is y is equals to b to the power of x. We're just going to substitute its value, since we already identified the given. So our y is equals to 3x minus 1. Our b is equals to 5. And our power x is equals to 1. So let's go back with our main solution. So we are also going to express that into exponential inequality, since our problem is about logarithmic inequality. So for our y, we have 3x minus 1, then copy the inequality symbol, which is less than or equal to. Then our b is that 1, 5. And our power x is that 1, which equals to 1. So after this one, we are now going to solve for x, applying the addition and division rule. So to do it, we are going to add 1 in our left side. Since we are adding 1 in our left side, we also need to add 1 in our right side. Then after that one, we are going to solve for this number, negative 1 plus 1 is equals to 0. So the remaining term is 3x. Then copy the inequality symbol. Then solve for 5 plus 1 is equals to 6. As we can observe, we still have a term which is 3x. Okay, so what we are going to do with that, we need to divide both sides by 3. That is by division rule. So we are going to copy that 3 there and divide it by 3. Then copy the x, copy the inequality symbol, then copy the 6, divide by 3. So solving it, we have 3 divided by 3 is equals to 1 times x is just equals to x. Copy the inequality symbol, dayon. Then we have 6 divided by 3 is equals to 2. So our final answer is x less than or equals to 2. So for our solution set, that is equals to 0 to 2, since all logarithms must be positive. And this 2 here is part of our solution. Then let's proceed with example number 2. Solve log of 2x minus 1 greater than log of x plus 2. So we're going to copy the given. So as we can observe there, we cannot find any base. So it means that there is a hidden base there which is equals to 10. So any logarithm that doesn't have a base, so that is called as common logarithm. So it is just a hidden base there. There's just a hidden base there. So we are going also to have a hidden base there which is equals to 10 in that portion. So after that one, we can now have our base which is equals to 10. We all know that 10 is greater than 1. And therefore, b which is equals to 10 is greater than 1. So for our solution, since b is greater than 1, then the direction of our inequality will be retained based on our property number 1. So I'm going to show you. So that is now the result. So as you can observe that the symbol is retained. So after this one, since we all know that both our logarithm have already the same base, which is 10, and that is hidden. So what we are going to do next is just to copy the expression which is 2x minus 1. Together with the inequality symbol which is retained, then we have x plus 2. So after this, we are going to solve for x. So in solving for x, we are going to apply the subtraction, the addition, and the division rule. So to do it, we need to subtract x in our right side. Since we are subtracting x in our right side, we are also going to subtract x in our left side. Then we are also going to add 1 in our left side. Since we are adding 1 in our left side, we also need to add 1 in our right side. So solve for like terms. We have 2x minus x is equals to x. Negative 1 plus 1 is equals to 0. Then we are going to copy the inequality symbol which is greater than. Then x minus x is equals to 0. Then we're going to add 2 and 1. The result is equals to 3. So our final answer is x greater than 3. So the solution set is equals to 3 to positive infinity, where 3 is not part of our solution. So let's proceed with our last example. Solve log of 2x plus 3 with a base 1/2 greater than log of 3x with a base 1/2. So we're going to write the given. So that 1. So as we can observe, our base is equals to 1/2. And we all know that 1/2 is less than 1. And we also know that 1/2 is greater than 1. Therefore, b, which is equals to 1/2, is greater than 0 but less than 1. So for our solution, since b is greater than 0 but less than 1, then the direction of our inequality here will be reversed. That is based on our property number 2. So I'm going to show you. So as you can observe, that symbol there, greater than, will be reversed. It will become less than. So after this one, since we know that they have already the same base, which is 1/2, so the next thing that we're going to do is just to copy the expression, which is 2x plus 3. Then copy the inequality symbol, which was reversed. Then we have 3x also in our right side. So after this, we're going to solve for x. In solving for x, we're going to apply the subtraction and division rule. So to do it, we need to subtract 3x in our right side. Since we are subtracting 3x in our right side, we also need to subtract 3x in our left side. Then we need also to subtract 3 in our left side. Since we are subtracting 3 in our left side, we need also to subtract 3 in our right side. So solving for like terms, we have 2x minus 3x is equals to negative x. Then 3 minus 3 is equals to 0. Then we're going to copy that inequality symbol. Then we have 3x minus 3 is equals to 0. Then we have that remaining number there, which is negative 3. We're just going to copy that one. Okay. So after this, since we all know that we still have a negative term, which is negative x. So we still need to solve this one. So to do it, we are going to apply the division rule. So applying the division rule, we need to divide both sides by negative 1. So we're going to copy that negative x there, then divide it by negative 1. Copy the inequality symbol. Then we have negative 3 divided by negative 1. Solving for this part here, negative x divided by negative 1 is just equals to positive x. Then copy the inequality symbol. Then in the right side, we have negative 3 divided by negative 1 is equals to positive 3. So for our final answer, we have x less than 3. So for our solution set, that is equals to 0 to 3, since all logarithms must be positive. And this 3 here is not part of our solution. So that is all about solving logarithmic inequality. Thank you.